Hello there, welcome to the 19th video of learning everything we can learn from VisionOS Documentation. Here we're gonna look at the monitoring playback progress in your app article, which is about observing the playback of a media asset to update your app's user interface state. Media playback apps commonly need to monitor playback progress to drive the state of a player UI, or perform other actions. Monitoring this state requires a higher level of time precision than key value observing can deliver. So Player provides specific APIs to observe playback time. This article describes how you can observe this state at regular intervals or as playback crosses specific time boundaries. Observe the current playback time at regular intervals. The most common way to observe a player's current time is at regular intervals. Observing it this way is useful when driving the state of a time display in a player user interface. To observe the player's current time at regular intervals, call it add periodic time observer for intervals queue and using method. This method takes a CM time value that represents the interval at which to observe the time, a serial dispatch queue, and a callback that the player invokes at the specific time interval. The following example adds an observer that the player calls every half a second during normal playback. Here we have two variables, published private variables, duration and current time. Here we have our AV player, and we need to create a time observer. Here we're going to add an observer to the player timing, add periodic time observer, let interval of CM time a value of 1, time scale 2. So 2 times every second. Time observer is equal to player dot add periodic time observer for interval, and the main queue with a closure of weak self time in guardless self else return. Set the current time to be equal to the time found at the second, and the duration is the player.currentItems.duration.seconds or 0. Lastly, we have remove periodic time observer, which does a guard time observer else return, and we'll do a player.remove time observer, the time observer we created, and set that to nil. With that, we have another bit of article here. Always pair a call to the player's add periodic time observer for interval queue using method with a call to remove time observer. When you're finished monitoring the states, failing to observe this rule results in undefined behavior. Let's talk about the time observer in our code. Here in the player model, we have our add time observer function. The first line of code we have is remove time observer. That is different from what we've seen in the documentation. The reason why I believe that remove time observer is here is because we want to make sure that we don't have two time observers running at the same time. So we should remove it first before adding a second one. Now, here in terms of time interval, we have 1 time per a second, and we add the periodic time observer for the time interval on the main queue. And for this time, we are going to set self equals self, set the duration, and if it's in the proposed time range, if time in seconds is greater than the duration of seconds minus 10, then what we will do is that we should propose the next video. So if we're within 10 seconds of when the video finishes, we'll propose a new video for the viewer. Here is our remove timer observer, which is exactly the same as before. With that, I believe that we are ready to move on. All right, let's observe the playback of specific times within a media presentation. Another way to observe the player is when it crosses specific time boundaries during playback. You can respond to the passage of these times by updating your player UI or performing other actions. To have the player notify your app as it crosses specific points in the media timeline, call the player add boundary time observer for times, queue, and using method. This method takes an array of NS objects that wrap CM time values that define your boundary times, a serial dispatch queue, and a callback closure. The following example shows how to define boundary times for each quarter of playback. Here we have created a function called add boundary time observers. It's an async throw function. The reason why we need to make sure this is await is because we need to await the asset load function for the duration. Once we have the duration, we'll cut it up into quarters using the quarter duration function. Here at CM time multiplied by ratio, getting the duration, the multiplier at 1 and 4 divisors. After which, we're going to create a CM time at 0 and start entering these times into the times array of NS value array. While the current time is less than the duration, we'll set the current time to equal current time plus the quarter duration, and we'll append this time to our times array with this current times and NS value. After we do so, we're going to take all the times of NS value arrays, like we have talked about earlier, in the main queue and pass in a closure, callback closure, which will use the information about from the time observer to update our UI. Lastly, if you add either a periodic or boundary time observer, you need to remove observations by calling the remove timer observer when complete. I looked into the code and there's nothing similar here, and I think that this is good for now, and we'll move on to the next article.